All right, so here we're going to learn about logarithms. So an introduction to logarithms is this. An exponential function and a log function are inverses of each other. And so basically it goes like this. Like let's say you have a statement that says 4 to the second equals 16, right? That's a true statement. So the log version of this statement would be log. Now, when you write the word log, it has a base, so it has a subscript. And so you put the base over here is 4 squared, 4 is the base, so you put a base 4. You put the 16 next, and then you say equals 2. So when you have a log statement, it goes like this. You have your base, your power, and then your answer. So kind of like a circular thing here. So here to here and here to here. So if I were to write a statement like this, log base 2 of 8 equals 3, that would mean in exponent form, here's my base, my power, and my answer. So that means that this has to be true. 2 to the third equals 8. Okay, so you have log form and exponent form, and I guess I kind of did that. I was going to do that over here, but a logarithm is just the inverse of an exponent. It was created to be the inverse of an exponent, and so with logs, you have your base, you have your power, and you basically have your answer. So you have A to the C equals B. All right. So when you do that down here, now the normal base for like the generic base is going to be base 10. So we have a basic log function. We write log base 10 of x. Now that base right there, if you can also write it like this, y equals log of x. Okay, so that 10, if there's no base, then you're assuming it to be a 10. Okay, so like look at these problems here. You see how this has base 2, but this doesn't have a base. So you're assuming this is a 10, this is a 10, and so forth. Okay. All right. So let's look at our graph. So we're going to do this graph. We have to remember our exponent function. Our exponential function has a horizontal asymptote. Logs are the inverse of exponential functions, so they have a vertical asymptote. Right? And the graph of the exponential function went through the point 0, 1. So we're going to go through the point 1, 0. Sorry, my dog wanted in. And if we go ahead and think about some more. So let's look at some more information here. So let's see. So plugging in 0 is impossible, right? Because that's our asymptote, that red line there. If you put a negative number in, so let's try this. Log base 10, and remember the x is after this. So let's put like a -2, let's say, equals. So I have to figure out, so I'm trying to do this one. I have to try and ask myself, 10 to what power makes -2? So 10 to what power makes a -2? Well, that's never going to happen. 10 to a positive power will make a really big positive number. 10 to a negative power is just going to turn into a fraction. There's no way I can turn this into a negative answer. So you are not allowed to use negatives. Okay, you can't take the log of a negative. You also can't take the log of a 0, because watch this, log base 10 of 0. So 10 to what power makes 0? There's no such thing, because even if you put a 0 as the power, 10 to the 0 is 1. So can't do it. All right, so we could continue plugging these things in. Let's do a 1. Log base 10 of 1. So 10 to what power makes 1? Well, 10 to the 0 makes 1, so this answer is 0. So that's our point right here. And for the rest of these, we kind of need a calculator. So on your calculator, if you want to do, log of 2, So you'd go to your calculator and you'd press this log and you put a 2. All right? And if you want log of 3, and so forth. So it grows, but it's growing very slowly. So 0.3 and 0.448. Did I do 2 and 3? Yeah. Okay, so basically your graph ends up looking like this. It rises very slowly, and as it goes to the left, it comes towards the asymptote. It goes right next to it. Okay, so your domain. Your domain is everything to the right of 0, so from 0 over. So basically from your asymptote over. Your range is from negative infinity to infinity. You know, this obviously goes down forever. As this goes right, it creeps up, so it gets higher and higher and higher. But, okay. Mins and maxes, none. X-intercepts, it does have an x-intercept at 1, 0 for now, and doesn't have a y-intercept. Increasing interval from 0 to infinity. This thing is increasing the whole time. Decreasing, none. Vertical asymptote, x equals 0 for now. And behavior, as x goes to negative infinity. So I should have put as x goes to 0 because we can't go to negative infinity. So as you go towards 0 from the right, this graph is going down forever. And as you go to the right, this graph goes up forever. Okay. So some transformations just like before. You know, like if you want to move it left and right, you do log of, let's say, x minus 2. So it moves it to the right 2. So moving it to the right 2 changes your vertical asymptote. And that kind of linchpin point of 1, 0 moves over to 3, 0. And there you go. And then to move it to the left, you'd put a plus, right? Your vertical asymptote is x equals 2. All right, up or down. So let's say you had log of x, and then you put a plus 4 on the outside. So there's no change in the asymptote. Still at x equals 0, but moving things up 4, so that would be up here, and then the graph would just be up top. Okay. All right, reflection over the x-axis. So the asymptote would not change, and you could also reflect this over the y-axis. We'll do that too. And so your graph would come up and go through here still, but go like that. Kind of looks like an exponential function. All right, if you want to reflect it over the y-axis, and the equation would be, you know, negative log of x. If you want to reflect it over the y-axis, you would do log of negative x. And so then your graph would look like this. And the asymptote would still be in the middle. All right, just like before, a dilation or a stretch, if you have a multiplier, let's say you had like a 2 log of x. So that would just mean that your graph, if you plug in the 1, you would still get 0 because 2 times 0 is 0. But this graph over here, it would just rise faster, be taller faster, and then this one would still come down here, asymptote here. A shrink, so over here, what would happen? You'd still be going through here, but you'd be shorter, right? Because you're multiplying by, let's say you're multiplying by 1/2. And I made these all base 10. They could be other bases. It's fine. All right, so let's do this guy. Log of x minus 1. So that's going to move to the right 1, which means my asymptote is moving over to the right 1. And then my graph is over here. And again, we're just doing sketches of these. You know, you can go into Desmos or your calculator to get a more finite, more pretty picture. So my vertical asymptote is at x equals 1. And it's important to also note the domain, right? So a big thing about this is that we want this part of the problem has to stay greater than 0. So x minus 1 has to be greater than 0 for us to be able to get answers. So if I solve this, it means that x has to be greater than 1, which is also, if you look at your picture, that's literally where the graph exists. It exists to the right of 1. So you can look at the picture, or you can solve the part after the log. Either way, we know that the graph goes from 1 to infinity. All right, here, log base 2 and then it has a of x, and then plus 3. So this right here is an upwards 3. So the asymptote is not changing. So notice how this does not have parentheses like this one did. So that means that the 3 is on the outside. That means like this is done, and then the plus 3 is afterwards. So the domain is everything to the right of 0. And up 3 is going to put us like right there. Okay. All right, vertical asymptote on this guy. So this guy's moving to the left 2. So it's going to be x equals -2 for my vertical asymptote. And that's also going to be my domain, something to do with it, but it is getting reflected, so let's wait till the end to do that. All right, so we're going to take our graph, we're going to move it to the left 2, 1, 2, and then down 1, and then reflect it over the x-axis. So normally my graph is going to be coming up like this, but now it's going to be coming up down here. All right, so I'm going to erase that. I just had to imagine how that went. Okay, so left 2, down 1 there. And there we go. Okay, this next one here. So, oh, my domain is everything to the right of -2. So, all right. So over here, what's my new 0? So right here, 4 is the thing. Like, so this thing is moving to the right 4. So x equals 4 is my new asymptote. Now, what's weird about this is what's happening here is the x is negative, right? And so that's going to cause a reflection over the y-axis. It's in a left and right reflection. And it's also moved to the right, or up 1. So this is going to go there, and it's going to be up 1, but also right 4. So there's my new point, and everything's there. There. Okay. All right, so that one's a little bit tough, but whenever the x is negative in there, it creates a reflection over the y-axis. And my domain is from -infinity, looks like, all the way up until 4. And you know, if you need to, you put this in Desmos, log of 4 minus x. If you want the log function, you can literally type the word log, or you can go in your functions, and near the bottom, I think, nope, there it is, log 4 minus x, and I forget, it was a +1. When I was zoomed out before, looking at some huge picture. There we go. So it's going to be kind of hard to see. All right, oh, there, that's good enough, yeah. So, and if you need a point on there, you know, you can always tap on it and get any point that you need on there. Okay, I think that'll do it there.